So in the earlier lecture I talked about a consequence, very important consequence of Lorentz transformation, that is length contraction. Now today I am going to talk about another very important consequence, that is also a consequence of Lorentz transformation, and we call that as simultaneity of events. Simultaneity of events. So let me talk about that, right? So first of all, what is the meaning of simultaneous events? So two events are said to be simultaneous or said to occur simultaneously if interval between them is 0. So this means that simultaneous events takes place at same instant of time, though not necessarily at the same point in space. Let us try to understand that. What does it mean? So consider frame of references. This is one frame of reference, and say it is another frame of reference, right? And this is x-axis, this is y-axis, and say it is z-axis, and it is z-prime axis, it is x-prime axis, and say it is z-prime axis. And this is the moving frame of reference, and it is moving along this direction with velocity v. And say one event is occurring here and another event is occurring at here. Say this event is represented by x1 prime and t1 prime, and this event is represented by x2 prime and t2 prime. Means when seen from this s prime frame of reference, then these two events are represented by x1 prime and x2 prime. And when these two events are observed from this S frame, means it is the S frame, when they are observed from this, then its coordinates represented by x1 t1 and x2 t2, right? So let us talk in terms of S prime frame. So these are the two events, and they are represented by x1 prime and t1 prime and x2 prime and t2 prime, right, when they are observed from the S prime frame. Now according to definition, that x1 prime and x2 prime need not necessarily the same point, they are the different points. x1 prime and x2 prime, they are the different, but for these two events to be simultaneous, in S prime frame, their t2 prime must be equal to t1 prime. This is the definition of simultaneity of events, right? Or we can say that t2 minus t1 prime, it must be equal to 0, right? That's the meaning of the simultaneity of events. Now I will check whether these events seems to be simultaneous. Check whether these events seems to be simultaneous or not in S frame, right? So what will happen to them? Let us see. So now let me try to evaluate now T2 minus T1, and this T2 is basically, if I apply the Lorentz transformation over T2, then I can say that it is T2 prime plus Bx1 prime over C square 1 minus P square over C square under the root. This is the value of T2 in terms of prime frame, and the T1 can also be written as T1 prime plus Bx over C square, sorry, x2, it is 1, right? Yeah, it is 1, and here it is 2 over 1 over 1 minus B square over C square under the root. That's what we are getting. Now let me simplify it. This is T2 prime minus T1 prime plus it's plus, yeah, it is Vx2 prime minus x1 prime over C square whole divided by 1 minus P square by C square under the root. But since event seems to be simultaneous in S prime frame, so that's why this quantity will be 0. So this makes that T2 minus T1 is equal to V over C square x2 prime minus x1 prime upon 1 minus P square by C square. And this is not equal to 0 because x2 prime minus x1 prime, they are different. So this means that two separated events observed simultaneous. Separated means x2 minus x1, this is different. This because of this I have used here the two separated events. Two separated events observed in simultaneous, observed as simultaneous by an observer in S prime will not appear as simultaneous to an observer in frame S, right? That's what we are concluding out of this. So in this lecture I talked about simultaneity, and need not necessarily that simultaneous events are simultaneous in a different frame of reference. They need not necessarily be the same, right? That's what we are getting out of it. Now in the next lecture I will talk about the time dilation. So that's all for this lecture.